9.4 is scientific notation. I'm going to leave this up here for you to look at scientific notation, but you guys should really know how to do this. Scientific notation, the first number has to be between 1 and 10. So you'll notice that with 16 million, the number they chose is 1.6 because 16 would be too big, 0.16 would be too small. 1.6 is right smack in the middle. Now, yes, it's always times a base 10 with an exponent on there. So the numbers you're going to be replacing are this first number and the exponent. The exponent doesn't tell you how many zeros. Look, there are 6 zeros there, but the number they chose was 7 because it's not about the zeros. The exponent tells you how many times to swing the decimal. And if you put the decimal here between the 1 and the 6, you'd have to swing it once, twice, 2, 3, 4, 5. No, I lost count. 1, 2, 3, 4, 5, 6, 7. It takes 7 swings to get from 1.6 to 16 million. Now, a negative exponent means a fraction, right? Well, what's another way to write fractions? Decimals. So you got a number between 1 and 10. That would be 2. So the decimal would be here. They've moved it 1, 2 places, but they've created a decimal value in the process. So you should have a negative exponent. Big numbers have positive exponents, small numbers have negative exponents. So here, the number you'd have in front is 7.82, 7.82, and the exponent, come on now, exponent would be 1, 2, 3, 4, 5, 6. And this is a positive 6 because it's a big number. Here, your front number would be 4.01 because that's a number between 1 and 10, and you can't get rid of that 0 placeholder. Now this one's a small number, and I put the decimal right here between the 4 and the 0. How many swings does it take? It takes 3, but this is a small number, so it's not 3, it's negative 3. So be careful how you do this. So this is 3, 8, 9 with 4, 5, 6, 7 zeros because it took 2 swings just to get around the numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. Now a negative exponent means that we have a small value, a decimal. That means I've had to swing around the 9, and I have 1, 2, 3, 4 zeros. Count that, make sure. My decimal was here between the 9 and the 0. 1, 2, 3, 4, 5. So converting back and forth, no problem. The new part for you guys is going to be this example 4. Go ahead and skip the other stuff. Multiplying and dividing and taking powers of all of this. This is just still one big multiplication problem. So 5.6 times 10 to the negative 4th times 1.4 times 10 to the negative 5th. They've reorganized it based on the commutative property. And all you got to do is take 5.6 times 1.4. And I'm doing what you're doing. Grab my calculator. 5.6 times 1.4, it gives me 7.84. Now, 10 to the negative 4th times 10 to the negative 5th. Same base, so keep the base. But what are we going to do with the exponents when we're multiplying? We add our exponents. This answer is literally 7.84 times 10 to the 9th. The same thing works for division. Notice how they split up this division problem. 3.5 divided by 1.75 is 2. I actually did the division. I divided. Now, 10 to the negative 3rd divided by 10 to the negative 5th. 10 to the 5th power wants to be in the numerator. Oops, sorry. 10 to the 5th power, undo. There we go. 10 to the negative 5th power wants to be in the numerator. That wants to be in the numerator. Now, 10 to the negative 3rd power wants to be in the denominator. What if you had 10 to the 5th over 10 to the 3rd? Now, what kind of value would that give you? Hopefully, your answer is 10 to the, I know I'll show it to you soon, 10 to the 2nd power. Now, letter B is an interesting one. You have 3 to the 2nd power times 10 to the 2nd power to the 3rd power. We are going to like we've done before, distribute this power out. So I'm going to take 3 to the second power to the third power, 3.2 to the third power, and 10 to the second power to the third power. Remember, power to a power, we multiply. Well, 3.2 to the third power is 32.768. 68 times 10 to the 6th. Now, do you notice we have all these extra lines like that's not our actual answer? It's not. Look at this first number. That's not between 1 and 10. We're going to skip these 2 steps because I'm pretty sure you can do this in your head. Where could I move the decimal so it would be between 1 and 10? Well, right after the 3. 3.278. Well, from here, it had 6 places to move. If I move it here, now how many times does it have to move? Well, if it was 6, now I've got to move it 7 times. So think about where this would have to go now. So from here, it had 6 swings to go. So now if I move it there, it's going to be 7. Think about how that's going to change if things are backwards. That's really pretty much all you need for this lesson, so I'm going to stop it here.